So yes, so tell me about any questions that you guys might have had on the previous days, anything that was difficult, anything that you want to discuss. Let's do that while we're waiting for other people. I'm looking at the chat, so if you guys can just put it in the chat, we can have a look. Okay, so I'm assuming there aren't many questions. So let's start with the first discussing the project. So I've seen that there you guys haven't registered or put your team information on the link that is in the course instruction website. Please do it. So projects, it doesn't have to be something super complicated. You can do simple things. For example, I'll give you a few examples. Let's say somebody wants to work with MNIST dataset, the dataset that we are looking so far. So what you can do is you can take MNIST images and randomly move around some pixels for all training set and test set. Then train on this permuted data set, train your network and see how accurate it is. This will give us some important insight into convolutional neural networks. But anyway, this is one idea. Okay, there are data sets. There is a data set which is called Fashion MNIST. You guys can use that. It's a classification data set. You guys can use Cypher 10. It's also a small data set. So anything like any problem on this small data set would do. I just want to see how you guys handle data loading, how you guys handle creating a network, how do you guys handle training of it and things like that. Okay, so are there any questions about what to do in the mini project for this course? If not, can anyone just put a yes in the chat that they understand what needs to be done? Okay, so I'm not getting any yeses, which means that there are questions about what to do in the mini project. If there are questions, please ask them so that we can, okay, what are these other databases about? So these are classification data sets. So this has like 10 classes of like shirts and shoes and these kind of things. Just like in Nest, I think it's also 28 by 28. But it's a classification data set. We have to classify things. Similarly, Cypher 10 is also a classification data set. It has classes like, I think, cars or something like that, animals or something like that. But 10 classes, I think, as well. Same type of setup as MNIST. The only thing is that this is RGB. It has 3 channels. That should not be a problem. Okay. So who has any questions? Who else has any questions about what to do in the mini project? Because you guys would start working on it today. What should we include in our project report? Just like what was the data? What does the data require? How did you set up your network? How many layers it had and things like that. What was the performance? How much accuracy did you get on the test set and things like that. Just simple, like just a transcription of, because I want to see the thought process of like how you guys set up this deep learning or machine learning project. Okay. Any other questions from anyone else? Okay. So is everyone clear about what we have to do in the project? I want to see some yeses in the chat, please. Okay. Okay, perfect. What should be recorded in the presentation then? Just the same thing that you probably would write in the report. Like, for example, we chose this data set asks this. This create like 4 or 5 slides explaining the type of data, the type of network that you used, the type of loss function, and how is the graph of the loss function during the training, how much performance did you get on the test set, which samples, if any, the network didn't work well for. Okay. Any other questions? Okay, I'm assuming that this makes things clear, probably. So today, the main lecture would be till 11. From 11 till 1, you guys can work on your project. I will be available in the chat, but I'll not teach anything new. We will not discuss anything new. Similarly, tomorrow also, from 11 till 1, we will not have any new topics. We will have that time put on the side for the project. Okay. Okay. So now let's come to today's topic, which is data loaders. Okay. So as we discussed yesterday, generally speaking, all the computation would be either happening on a GPU or a CPU. Okay. Mostly GPU. Okay. And GPU, I think even the top of the line GPUs would have like 32 GB memory. The earlier one probably would have 8 GB memory and things like that. So, and this memory, by the way, is used for storing the network and doing the computation on the network. Okay, calculating the backpropagation equations for the network and things like that. You have huge data sets in your hard drive. So this is your hard drive, and you have data set in there. Data set can have images, then maybe some masks for this images, maybe some markings on these images. Now, all this data has to be provided to the algorithm during training on the GPU. How do we manage it? How do we manage it efficiently, that is? Okay, we do not want to put all this data on the GPU and then ask the algorithm to use it. That's going to be too inefficient. So what we do is, at least in Python, in PyTorch, the pipeline is this. So let me draw this again. This is your hard disk. These are, let's say, images, masks, and let's say markers. Let's create a fictional data set, a fictional problem, where our loss function depends on 3 things. It's depend on the image, some marker location in the image, which is specified by this variable, and then some value for these marking, which are masks. Okay, you can think of them as labels as well. Let's say this is our deep neural network. It depends on these 3. For each sample, you have these 3 types of data. Okay, so the pipeline in PyTorch works like this. So from data, you create an object which is called a data set. This basically is somewhat similar to a long list of your data set. So what data set does it's take your raw data, arrange it in a format where you have a long list now, which has your samples. Okay, this sample can either have dictionaries, it can have lists, but the idea is this, that each sample would have the image, the mask, and the marker put together in one place. Okay, and then you can go over these samples by index. You can say index 0. Index 0 would be the first sample, index 1 would be the second sample, and so on. Okay, so data set basically is like an organized juxtaposition of your data, such that your data now, which might be stored in like random locations on a hard disk, now has this structure. You have a big list which has your samples, and then each sample has all the components of the data required: image, mask, and marker. So remember, this is exactly similar to what we saw yesterday when we had badge 0 was the image, and batch 1 was the label. So this batch is, think of it as sample. So does everybody understand what the dataset class does in PyTorch? It takes in the data and puts it in an organized form where we can access each sample of the dataset. Let's make it a little finer. I am trying to do it, but it's the finest one. Let me, okay. Yeah, I think that would be better. Okay. Okay, so okay, sorry. Any questions about dataset, what the dataset does? So it takes all your data, put it in organized structural format where you can access each sample of the data. Okay, and we will see how this is done. So I'll write a sample code here. We will actually implement it in Colab, but PyTorch has a class in torch dot I think utilities dot data set. So there is this class, and we would extend this class to create a class of our data set. Generally, how it works is we create a new class. Like, let me do it on a clean page so that we have some space. So we import torch dot utilities dot data dataset. Okay. Then we extend it. So we create a class, or let's say we call it my dataset. It takes in this class and it extends it. So of course, the first method, as always, is init. Init is used particularly to create the dataset object to specify the parts of your data, where the data is, and things like that. Okay. So generally, it would take in a self, it would take directories, probably a list of images. Okay. Now you need to specify you need to assign these values to the object. So I can say self.image list is equal to image list. So now the image list is stored inside the image list variable of this particular object. Similarly, we can do self.dir is equal to dir. It stores the directory. Now you need two methods to be defined inside this class in order for the dataset class to work correctly. One is length, underscore length, which defines how many elements are in your dataset. What is the total length of your dataset? So generally, if you have an image list, if you have a list of image, you can simply return the length of this list, length of self.im list. So this would return the length of your dataset. And the other method that you need is get item. Get item takes the object itself, of course, and an index, and it returns data corresponding to this index. Okay, so how does it work? So basically, you have to write some code which access the image correspond to this index. So I call it image get image corresponding to IDX. Similarly, mask gets mask corresponding to IDX, and marker gets marker corresponding to IDX. And then you return this in a sample, where sample can be a dictionary, it can be a list, it can be anything. These two, once you write these two methods, now you can create an object of this data set, of my dataset class, and it would arrange all your data in a nice organized form where you can access it as a list, all the samples as a list. Don't worry too much about it. We are going to implement it. I just wanted to give you guys an overview on the page first. Okay. Any questions, any confusions? We take the dataset class of PyTorch. We extend it to create a custom class for our dataset, which would take paths. And do we need to put underscore? Yes, yes, because it means that these are like internal functions inside this class. So I'm assuming that these would overwrite the length and get item methods inside dataset, and dataset class would use it to arrange your data. Are there any questions? Okay, once you have the dataset class, things become easy. You can just use torch utils data loader. So PyTorch has this data loader class, and you can just simply use this. You can create a data loader from your data set, the data set that you have created, and you can give it batch size. You can give it shuffle. We will see what each one of this do. And that's it. It would create batches for you. Okay, so the main bulk of the work is just writing this class. Everything else is it can be taken care of relatively well. So let's go to the code. And what I would do is, since we have worked on this MNIST data set, MNIST data set comes with like its own data loaders. But I want to get some images. Do we need to call it? No, we don't need to call it. We don't need to call this function. It's handled inside the data loader and data set functionality. Yes, super should be initialized here as well. Okay. Do we need only in need of inheritance other class? I did not understand the question, but these are the only two classes that we inherit from. We inherit from dataset and we use data loaders. Okay, so let me just explain what today's pipeline is. So basically what I would do is, first I need to create a data set in terms of images and some lists that I can then manipulate and use it. So what I do is, it's an ad hoc kind of solution. I go to MNIST data loader, okay, and I store images in this data loader in a directory. So I create a directory images, and I would store images as images inside this, and I will name them, okay? And I create a list of these as well. I say that, okay, the first image, 1.jpg has a class 1, 2.jpg has a class 2, and so on. So after I run this code, I have images in folder images, and I have a CSV file which has labels. Based on this, I take this data and then I write my data loader. Okay. Typically, you won't have to create your data set yourself. Data set would be given to you. But since I wanted to do it with like an easy data set, a data set that we had seen, so from the data, I first create the data set, and then from that data set, I wrote a data loader for it. Okay, so let me come to the code. This code, by the way, is shared already on day 9. If you want to look at it, we will rewrite it together here. But let me just go to my code. Okay, so let me start by taking in the appropriate codes. These are my libraries that I need. I need my data loader to access MNES data. And let me download this. Let me create a data loader of this instance. Okay. Okay, so I have this data set is downloaded. Now let's start. First, I want to access some images from this data set and store them on my machine so that they are in a folder and I can then write a data set for it. So how would I do it? So I would say, let's say for batch in loader. Okay. First, I need a global index for my data. So each image has to be labeled. I'll start with 0 and increment it every time. Then I need to go over each element of this batch because I want to access each image individually. So it would be range batch 0 dot shape 0. Remember, the 0th index is the index of the data. It tells you how many data points you have. So what do? I access each image. So image would be batch 0 J. This gets you the image. And the label would be batch 1 J dot item. Okay. So let's do it. Let's say that, let's see what do we have. I will do it. Okay, so seems fine to me, I think. Let's, okay. So you have a tensor, which is an image, and let's see what you have label, and then you have the label. Okay, so it seems like we have adjusted the data correctly. Let me use a library to store images. It's called GS. So this takes in a tensor and saves it as an image. So it's good for us. We can use it. And let's create a directory for our images. So I'll create a directory called images. Okay. Remember this, when you put this, it interprets as a terminal command or as a shell command. So let me just keep that. If there are any questions, please ask them in the chat. I'll just open it and keeping an eye on it as well. Okay. By the way, the code that I'm doing so far is just to create the data set. I haven't written any code for handling of the JTCP. Is anyone clear about the intention, what I'm trying to do actually? Entire makes a directory inside your current. Yes, it makes a directory in your current location. So let me do it. Let me show you this. So if I do this, you can see that there is a directory images here now. Okay, it has created this directory. Okay, is it clear? Okay, perfect. So now let's, we have the image, we have the label. Let's try to store this data somewhere. So we will create two lists. I'll call it image list and label list. Okay, and I'll do two things. I'll create an image name, image that I'm trying to store. Let's create a name for it. Let's say that its name would be the global index dot jpeg, and its label, of course I have the label. So now I can do image list dot append image name and label list dot append. Okay. So I have the image name and the label stored. Now let's just save the image. So if I save the image, I think I can just use all save image. It should take in the tensor and it should take in the path, which is, and this for me. Sorry, I have to give it and to give it the path as well. So this is images. Hopefully this should work. Let me just double check. So you get image lists, you get labels, and you store the current image in images/im name. I think it should be fine. I don't want to do it for the entire data set because it's like 60,000 images, which would be huge. I'm doing it for 2,000 images. I'm doing it for 200 batches. Each batch has 10 images. So you will have 2,000 images in your data set. So let's run it. Okay, that seems to be the issue. Let me remove the print command. Okay, so it's not images. It's to be done the other way. It's images and image name. Okay, it seems to be working, and let's see if we have this. Let's see if it shows all the images. Okay, it is just 0.jpg, which is exactly what we expect because we didn't update this. So the first image would be written as 0.jpg, the second image is 1.jpg, 2.jpg, and so on. So let's see. And it has all these images. You see that it has stored all these images. Images are created. Now let's create an image, a list, a CSV file, which takes in, where the first column is the name of the image and the second column is its label. Okay. So for this, I would use pandas. So Panda is a library in Python which is used to handle data. Pandas as PD. This part, I will go through it quickly. You don't need to worry too much about it. Just because you would not create this yourself, you would be given it. I have to create it because I have to create a custom example. So let's see. Let's create PD. Okay, let's call it DF data frame equal to PD dot data frame, and I think it's called data is equal to zip my two lists. So my lists are image underscore list and label underscore list. And then I have to give it column names. Column names are, let's call it name, and sorry, let's call the first column would be called name and the second column would be called label. Let's hope that this works. Print df.head. Df.head shows like the first 5 rows of your data. Okay, and it got unexpected column. Let me just look at the right name for it. Okay, so this is called columns, and the rest is fine. Okay, so you can see this is how my this file this data frame looks. It has the name of the image and the corresponding label. Okay, so now we can store this file. We can store it in our hard drive somewhere. So we can say store it, and let's call it image list dot csv. Okay, so now if I do this, I have my image list and I have my images. Now we are set to write a data loader. Okay, so let's set out and write a data loader. You guys have to help me now from the discussion that we did earlier as to how to write it. So let's start. So the first thing I do is I call my dataset class my dataset. It inherits from, oh, I have to import them, but let me just write it. So let's import the library. So I'll say from torch.utilities.data import dataset and data loader. Okay, so I have both my classes. Now, what should be the first function of this class, as is the case with any other class? What is the first method? Come on, guys. Yes, thank you. Init, it will take in itself. I need to give two things to, I want to give it an image path because it needs to know where images are stored, and it takes in an image list. These are the two things that I need in my framework. You can, of course, come up with any logic to do these things, but the logic that I have in my mind, I need these two things. So I'm going to assign these things to my object. So I'll say self.impath is equal to impath, and self.imlist is equal to imlist. Now that's pretty much it. Do I need anything else? Okay, no, I need something else because this is going to be the name of the file. It's CSV file. I want to extract the list from it. So what I can do is I can say pd.read underscore CSV and imlist. So it's going to read the file. Let's not call it imlist. Let's call it imlist file so that there is no confusion and we know exactly what's going on. So this has the name of our CSV file. We read this CSV file and place it here. Okay. So now, once we have this, we need two things, as we have pointed out. In fact, let me do. let me break the data here. So basically, what does this CSV file have? The CSV file has two things. One is it has a column with the image names, and it has a column with labels. So I want to separate these two. So I'll call this, let me just remove it. I'll call it data, and I'll say self dot image names are my data frame, which is, let's call it data frame, my data frame column, which is called name. So this would give me all the names of my images. Remember, my data frame looked like this. So it has two columns. One is name and one is label. So I want to extract this. I want to extract the name of my images. So I say go to my data frame, extract the names, and I think it's called toList, and convert it into a list. Okay. Similarly, I want to do it for the labels, or just let's call it labels. I'll go to my data frame. I'll extract label. It's called label. And I want to convert it to a list. Okay. So now I have my image path here. I have my image names here. I have my labels here. Is it clear? Shouldn't these be variable to string? I don't understand the question, Aljaz. What should be variable to string? Oh, I'm sorry. Sorry, I don't need this. These are just variables. I don't know why they're, okay. Thank you. Yes. So now I have my data initialized. Let's work on the two methods that we discussed. What are the two methods? The first method is it should return the length of my data set, of my current data set. How can I return it? Remember, I have the name of all the images in a list. I have the label of all the images in a list. How can I return the length of my data set? I can look at the length of any one of these. I can either look at the length of self.labels or the length of self.image names. That would give me the length of my data set. So I can just return length of self.image names. Is it clear? Does everyone understand why this should work? Why this should give me the length of my data set? Because I have the name of all my images, right? If I find the length of this list, it would give me the total number of images. Let's write the second function, the second method that we need. It's get item. It takes in the object itself and it takes an index and return the sample at that index. So how would I do it? So I'll say image is equal to, I need something to read images with. So I will import image Okay, so it should be image dot read, and I have to give it the exact path of my image. So what are the image paths? Where are my images stored? They are stored in self.image path. So this should be self dot image path, and I want to access the ith element. So the ith element would be, or the index, the element which is index by index. No, it's a bad choice of variable name, but anyway, the index element, self dot underscore names index. Does everyone understand what I'm doing here? So I go to my path, I select this element from my image list. Okay. So I go to my variable and I select this element and I say, okay, just read it. This is my image. Should there be a slash between those two variables? There should be a slash, but I'm going to give a slash in my image path variable. So I will say that my path is images /. Okay. So that would adjust it, or you can write it here. It's fine either way. Okay. And the next is label. We need to get the label. You guys have to tell me what is the label. How do I get the label of the index element? I will wait for you guys to write in the chat. Thank you. Yes, that's exactly what it is. So we have to go to self.labels and get the index element. Okay. Now you have to return the sample. And since, if you remember, for the MNES data set, the sample was a list. So I'm going to keep it a list. So I'm going to say sample is equal to this. It's a list. And sample dot append image and sample dot append label. And then return it. That should do. That should arrange your data set in a nice manner. So let's run it and see if everything is good. Let's create your data set. So I'm going to call it data set, and my data set. What does it take? It takes two things. It takes the path of my images, and it takes the path of the name of my CSV file. What is the name of my CSV file? Image underscore list.csv. .csv. So let's see, it works. It worked. So let's look at the first element of the data set. Okay. So object does not have an attribute image path. Why it doesn't have an attribute image path? Because it's called im underscore path. Okay, so it seems like it's working. You have the image and you have the label. Okay, so let's do something a bit smarter. Let's say that you take the first element of this and prints its shape. Okay, 28, 28, 28, 3, which is fine. It's an image. That's what we expect it to be. Let's see if we can use a data loader directly on it. I have a feeling that we have to use transpose to put it in number of channels, number of rows, number of columns format. So let me do it. Let me transpose the image. So im is equal to np dot transpose. Takes in the image and transpose it, put in the third dimension first, then the first dimension, and then the second dimension. So let's run it now. Okay, so this is good now. Now we have to create a data loader. So let's call it train loader. And as we discussed, it just take in the data loader. You use the data loader class, give it your data set, give it your sample size, which in this case, let's say I would take 4 samples, and you give it shuffle. Shuffle is whether you need to shuffle the data every time you create batches from it. So you should do it in training, and you don't need to do it in testing. So let's run it. Okay. Sample size. Oh, sorry, it's batch size. Okay. So now let's see if I can go over the batches for batch in train underscore loader. What should I do? For j in range batch 0 dot shape 0. Uh, so let's say that first, let's just do it for the entire print that 0 dot shape batch 1 dot shape. I want to print the shape of my batches. Okay. What does it say? Must. Okay. So one of the thing is for data loader to work, you either have to give it NumPy arrays or tensor. So we have to convert this into a NumPy array. So I think it's something I think np dot array. Let's hope that this works. List object has no, of course, it doesn't have an. Yeah, I just want to show that it has created batches. I just want to show that your data is in batches. You have batches of data. So let me do this. Print batch. Okay, so you see that it's indeed it has the batch. So let's see what is batch 0. So let's put batch 0 dot shape. Why does it say list object has no? Batch 0 should not be a list, right? Batch 0 should be. Let me see what mistake I'm doing. So batch is a list, of course. So let me do this. I'm sorry, I'll be with you guys. Let me just debug it. This is because it's not MP array but a dot tensor, I guess. But it can work for NP array as well. It's absolutely fine to use it for NP array or torch tensor. So let's do x dot shape. Yes, you can call this here as well. Okay. So I'm in this tiny bug somewhere. Let me try to debug it. What's the mistake that I'm doing? I'm giving it data set, which is my data set. I'm giving it a batch size and I'm giving it a shuffle. It should work fine. Let's see what I did in my code. Okay, so this is I just define my data set and then I just give it loader this, and this seems to work fine. So it's going to be because of shuffle. I doubt it. I doubt that it would be because of shuffle, but let me remove it. Give me 1 second. I have to debug it. So, debug as array. Maybe this is the problem. It must be a tiny mistake somewhere, some tiny bug that I have, which I haven't figured out how to solve yet. You can call shape on tensor, by the way, the question in the, okay. I append these, I return it. Let me run it for you guys here. This is the exact same code. I don't know what tiny bug I've made there. So why did you use? Because it expects the output to be image. It gives like a data type which is defined in this image library. It is NumPy array, but it's like image.util, some different class of data. But data set and data loaders expect NumPy or tensors. So I converted it into NumPy. I said, okay, use NumPy instead of this. So let's run this. What if you append it as it is? We did. This was the first thing that we did, and it created an error. It said that the class does not match. Okay, so this is for a previous data I have. I don't have this. I think it's called my image list.csv. Okay, so now it has, I have, uh, I have defined my two classes with different labels. Is not defined. Okay, so let's look at the sample here. Okay, I'm printing the class, so it's numpy and the array, which is what we want. Then we write a data loader, then we write, and it works perfectly fine. There is a tiny bug somewhere in my code. I have to figure out what it is, but this is exactly the same code. So I'm doing the exact same thing. I'm reading the image from the path, I'm transposing it, I'm reading the label, and I'm appending them in an array, and then I'm returning this data. I create the data set from this, an object of this class, and then I use data loader to generate batches of size 4. And then I print the batches inside this data loader. And you can see that it's absolutely fine. Everything is good. Now I have to see what the problem is in my code down here. So there is no like logical error. There is some bug, and we have to figure it out. So let me do this. This is actually a good exercise for debugging your problem. Let's look at the type of this. What type of data is it? Okay, that's the issue. So it's list, and we want it and numpy array. So I think this is probably where the issue is. I have to remove this, and I have to write it like this here. Okay, let's run it. Let's run it. Okay. Let's look at the type. It's still a list. Okay. So why does my image turns out to be a list? So I'm reading the image correctly. I'm doing the This might be the issue. It might, the transposition might be in place. Let's see. No, this, oh, it's my mistake and it's a stupid mistake, I'm guessing. So this is the issue. This is not the correct syntax of this. You have to give it in a tuple. Sorry. I was expecting it to work now, but it didn't. Okay, maybe we didn't evaluate. We have an extra equal to in self.label. I'm sorry, could you tell me the line? Which line is it? Line 19. So what is an extra? Yes. My data set has no attribute labels. So what is it called? Self.labels. Okay, it's still a list, but why? I'm actually, oh no, it has to be a list. I'm sorry, we have to look at this. So this is an in the array, and this is an integer. Hopefully this should be fine now. Okay, so it's fine now. The only thing was that there was a tiny mistake, like an extra equal to sign here. I don't know why, probably just a typo. But anyway, the thing is that let me just review it once again and get rid of all this. So first thing you have to do to play with a data is you have to write your own dataset class. Okay, dataset class basically has to have two important functions. One is a length function and one is a get item function. Length defines the length of your dataset, how many elements there are in your dataset. You can do it with any logic, any suitable logic. Just return the length of your dataset. And get item returns a particular item of your data. In our case, the item has two components. It has the image and the label. So I extract the two and return it as a list. You can return it as a dictionary as well. That should be absolutely fine. You can return a dictionary of data. That's fine. You can return a list and everything should work. Then once this dataset class is defined, you create an object of this dataset and give it to data loader, specifying a batch size. So if you specify a batch size, it would create a batch size of 4. If you specify a batch size of 7, it would get you a batch size of 7. So let me do this. So you can see now it's a batch size of 7. So this is up to you. That's like a very flexible tool of playing with your data through data sets and data loaders. So I'm going to give you guys some time to ask any questions if there are any. Let's do one thing. Let's try to return this sample as a dictionary and see if that works. So I'm going to say that this is image, and image is this, and I have the label as label, and then I just return the sample. This should also work. Let's run it. Let's run it. Now I have to, because it's a dictionary, I have to access it like this, sorry. Okay, so it's fine. Let's do this and batch image and batch. Okay, so it's exactly fine. You can create a dictionary or you can create a list, whichever one is more feasible. I think generally dictionary is much more feasible because you can access items by name rather than by index. Okay, any other questions? Any observations? Okay, so let's pause here. The code is on the website day 9. Let me save it so that you get the update version of it. Uh, Play around with it, get a feel of writing the data set, writing the data loaders. I would Let's try to meet around 10:30, 10:45, and I'll give a quick overview of how to incorporate transforms in your data loader as well. Sometimes you might want some transformation of your data, of your training data during training, and we would see how to do it. And from 11 onwards, you guys can start working on your projects. Okay? So let me stop sharing my screen and see you guys at, let's call it 10:40. Let's reconvene at 10:40 for the transforms. Thank you. Okay, guys, welcome back. Could you guys just leave a simple yes in the chat so that I can see who is back? Okay. Okay, perfect. So it seems like most of the people are back. So let me explain how you would use transforms in your data loaders and why they are helpful. So generally, you might have applications where you have a data set where images are of different sizes, right? Let's say some images are 256 by 256 and some images are like 400 by 512, something like that. Okay. When you want to use these images to train your networks, generally you want images to be of the same size in each batch. And if, for example, you have an image which is 256 by 256, an image which is, let's say, 400 by 512 in the same batch, it would not work because the array has to have consistent slices along all dimensions. So if you have cases like this, you want to use some sort of transformations to adjust the size of the data, let's say, to normalize the data. Sometimes you use it to augment the data. So you can, let's say, translate the images slightly, rotate the images slightly, and things like that. So all of this is done through transforms, and we would see some transforms and see how they are set up. So let me show you the code that I have here. So I have the same code. I've downloaded the data. I've created my data loader, and up till here. So let me write some code at this point and show you what my data loader is. Okay, so it's called MS data set. So let's say my data set is MS data set, and it takes in image folder and label CSV. So image folder is images, and the path for the file with the list of images is, I think, image underscore list.csv, if I'm not wrong. Okay, and then you can write like a train loader. Sorry, data set, and you give it a batch size. Let's say 10, maybe, I don't know. And everything should be fine. You have your data batch and everything. Now let's see, how do we incorporate transformations inside this data loader. So the transformations are incorporated inside data set. So what I do is I give it another argument, which by default is none. So these are my transformations. By default, it takes no transformation. But if transformations are given to it, it would apply these transformation and then return the sample. Okay, so this part is just like saying that if there are some transformations, apply those transformations. Now let's write some transformations. Let's create some classes of transformations and then use them. Okay, so generally you have to create a class of transformation. Let's say I create a transformation which I call, let's say, resize. This was resize my image. Sorry. I have to write the constructor for it. The constructor is take in a self and it takes in a size, and self.size size. And then I have to write another method which is called a call. It takes in the object and a sample, and then for this sample I take in the image. So image would be sample 0, because you can see that I'm inside my data loader, I'm appending the image first. In my data set, I'm appending the image first. So image is at list 0 and label is at list 1. So you can get the image, then you need to transpose it so that it looks like number of rows, number of columns times channels. So I can use np transpose image, and I'll give it 1 to 0. So now it's number of rows, number of columns times channels. And then I use a package. There is a from skimage import transform. So skimage has these transformations, and I would use the resize of these transformations. So I'll say image is equal to transform dot resize image and self dot size. Okay. Then I just simply transpose it again such that it's number of channels, number of rows, number of columns. So that would be 2, 0, 1. Then I put it back in its place, which is sample 0th location, and then return sample. Okay. So now we have created a class resize, which takes in a sample and resize it to a size which is defined for an object. Call, by the way, is a method which is used when you want to call the object by the class name. So you create an object and you want to call it by the class name, you use the method call. Okay, let's do this. We need, sorry, just could you specify the line? What's the problem? Of course, yeah, I need this. Okay, so now this is defined. Now when we create an object from our data set, we can just give it the transform, which in this case is called resize, and let's give it a shape 20 times 20. So remember, originally when we created our data set, all the elements were of size 28 by 28. Now let's do that. And now let's look at the first element of my data set 0 dot here. And then look at the image in it, and let's print its shape. So now it's 20 times 20. Okay, let's give it, let's say 15 times 15. Now it's 15 times 15. So you can see that we can apply transformations to the images in a very organic way. Okay, what if, let's say, we want to apply more than one transformation? Okay, this is a single transformation. What if we want to, let's say, resize the image and then normalize it as well? So let's create another class. Let's call it class normalize. And we create an init method for it. Normalize does not have, in this case, does not, we don't want to do anything. We can just omit init as well, but I just wrote it and put a simple pass in it because we don't have any variables to pass. Definition of normalize is independent of the object that you create for it. Then we have to define a function call taken self and sample. And then what we want to do is for image, which is sample 0, we want to do for each channel, we want to subtract the mean of that channel and divide by the standard deviation. So im should be im minus np dot sum. And what would that be? So let's do it step by step. Let's find the mean first. The mean is np dot sum of image along axis 0 and 1. Remember image is 1 and 2. Remember image is number of channels, number of rows, number of columns, and I will keep dimensions equal to true. Okay, now this is the sum of it. We have to divide it by the total number of samples to get the mean. So this would be np dot sum, or in fact, I can just do that. This would be image dot shape 1 times image dot shape 2. So this would give us the mean of the image, each channel, the mean of each channel separately. Okay. Now we subtract this from our image. So im is equal to image minus mean. Remember, since we have kept them true, the broadcasting will take care of everything. Now let's normalize it. So we want to divide the image by its standard deviation. So standard deviation would be np dot sum image square, and we want to do it along rows and columns. So axis has to be 1 and 2, and again we keep the dimension same, and then image would be image divided by standard deviation. Finally, we just assign it to sample 0, and we return the sample. Everyone understand what I'm doing? I'm just trying to subtract the mean of each channel from itself and then dividing it by the standard deviation to normalize it. Okay. I know I'm going a bit fast, but we'll re-go over it. I just want to finish the current session by 11. And I have I have a meeting actually to attend at 11, so to immediately rush to it. But anyway, I will come back to it if need be. So now if you want to do multiple things, which is a resize and a normalization operation, what you can do is you can use, so we have a package by which you can compose, compose as in like use multiple transformations at the same time. So I have, it's called import. In torch vision, we have transforms. And transforms allows you to compose different transforms, like use multiple transforms one after the other. How do we do it? A very simple syntax. You just do transpose dot compose. And then you give it inside square brackets the transformations that you want to do. So I want to do a resize, and then after that I want to do a normalize. Okay, it seems fine. Let me just run this normalized code first. I'm sorry. Okay. I'm not put in the square bracket. Okay, the spellings are incorrect. This is transforms. Okay, what is it called? Normalize. Normalize. Okay, so now let's look at the data loader. Shoot. Okay, so we have to, this is key dims. Sample is not defined. So sample. Okay, so now your data set is good. Let's print its value and see if this is indeed normalized. Some values should be positive and some should be negative, and you can see that it is. And they are between 0 and 1 as well. Shouldn't the normalize? Yes, it should be square root of this. You're right. So this should be np dot square root of this. Yeah, so now it looks much better. All the values are between -1 and 1, and they're normalized. So you can, the idea is that you can write any transform. You just need to write like a class for this, and then you can use their composition by using transforms.compose. Okay? Any questions? So compose essentially it takes the first transformation, stores it output, give it to the second transformation, and so on. So it's just simple composition of operations. Okay. You can, of course, like multiple ways, you can do it yourself. You can like create a dictionary, pass it through your data set, and then like, where is my data set definition? Yeah. For example, you can pass in a dictionary and then go over each element of the dictionary and then apply that transform yourself. But it's better to handle it through Compose because Compose take care of this process for us. Otherwise, it's absolutely fine to like pass in a dictionary. Then let's say the first element of dictionary is normalized. You normalize your data, and the second element of your dictionary is resize. You resize it here, and so on. You can do all of it here as well, but it's better to do it through transforms.compose because it's very neat and it takes care of it in a very organic way. Any other questions? Okay, so I'm going to stop sharing my screen. Let's take a break between 11 and 11:30. From 11:30 onwards, I would be available in the chat. We can have another session after like maybe 12, 12:15, 12:20. Maybe if there are some questions, we can do it. Some people want me to solve some questions, we can do that. But I will ask you guys at 12:15, 12, what do you guys want to do? You guys want to see some more examples of data loaders, or do you want to do some previous exercises? You might even want to discuss how you want to set up your project. What do you want to do for it? So yeah, but we will resume. The class would resume at 11:30. The session where I discuss something would resume at 12. Is it okay? Okay, perfect. I'm going to stop sharing my screen. I will be available in the chat at 11:30. Thank you.
Is
you guys observe any issues, anything that you think needs discussion, please put it in the chat and we can have a look at it. Even for the previous exercises, if there were any questions that you think needs discussion, we can have like a live solving sessions and we can solve it. Nawaf, you had some questions. Could you put it in the chat and I can have a look at them? Also, Nick, you had some questions as well.
Yes, teacher. Am I audible now?
Yes, you're audible.
Yeah, so basically I have some questions in terms of logistic regression model in the previous videos. So the first one is I want to know, what's the mathematically correct formula for z of x in the first step of logistic regression model?
Okay, so let me share my iPad. We can look at it. If I understand you correctly, you want to know what is the expression for z in logistic regression, right?
Yes, especially because the reason why all the what are the elements which make me feel confused is because I think you mentioned three types of notations. The first type about z of x is one dimension, and the secondly you mentioned about n dimensions. So finally you mentioned about two dimensions. So could you go back?
I got it. So basically z is the output of the linear layer, Wx. It's true for linear regression, it's true for logistic regression, it's true for even neural networks. So when I say z, I mean output of a linear layer, W1x. In terms of logistic regression, we just do z is equal to Wx, and then we pass this z through some nonlinearity. So sigma of z is equal to sigma of W of z, and this is your y hat. Okay?
Yes, I see.
In logistic regression, the output y hat was one dimension. So z is also one dimension. But when you have classification, multi-class classification problem, this z can be multi-dimension because it depends on w. W can be a row vector, in which case z would be a scalar. W can have two rows, in which case this is x, right? And this is w. So if w has one row, z would be a scalar, right? If w has two rows, the size of z would be 2 by 1. And if it has, let's say, c rows, then the output would be c times 1. Does it make sense?
Yes, Professor, it does make sense. So I have one confusion here because when the dimension of sample x is, if the dimension of the sample x is equal to 1, then the z of x equals w0 plus w1 x and plus w2 x powered by 2 and until wm times x powered by m. So what I mean is, if the dimensions of the sample x is equal to 3, and in this case, the z of x would be w0 plus w1x plus w2 w1 times x1 plus w2 times x2 and also plus w3 times x3.
I got your question. So basically, you're asking, what are these bases? So we can have two cases, right? We can have x in 1D, right? If x is in 1D, generally we take polynomial bases. We say w0 plus w1x plus w2x squared and so on, right? But what if x is in, let's say, 3D? What do we do? So we typically would do something like w0 plus w1x plus w2x2 plus w3 x3, and then w4 maybe x1 x2 and so on, right?
What I want to know is, in the last formula you have just mentioned, why isn't it including how to say, W1 W4 x1 powered by 2, and also W6 x2 powered by 2, and also W7.
It includes. So it would be W1, X1, X2. I should have said W4 would be X1 square. W5
Yes.
would be X1, X2. W6 would be X2, X3, and so on. It includes all the combination. If you look at our code, when we do it in
Yes.
code, we say for I equal to, for I in range number of bases, then we do it for each component. So we have Xi, X1i, X2j, and X3k. So this becomes 1, 2, 3, 4, 5. It goes through all the number of bases. So let me do like this. For j in range number of bases, and similarly for k in range number of bases. So it takes all combination of I, j, and k. So it would have x1 square, x2 square, x3 square. Then it would have x1, x2, x2, x3, x3, x1. It would have x2 square, x3 square. So it would have all combinations. Just think of this, right? I can be 2, j can be 0, and k can be 0. Then it's x1 square. I can be 1, j can be 1, k can be 0. Then it would be x1, x1 power 1, x2 power 1, and so on. Does it make sense?
Yeah, okay. Just a final moment. I want to make everything clear. So if we have a sample X which is in 3 dimensions, so for the first for the first dimension of a sample X which is equal to x1, so just for x1, it has basically how to say many weights, which is w0, w1, w2 until the number of the bases we choose. Is that correct?
That's
So
correct, but it's not entirely correct because we have all combinations of them. So what you're probably thinking is this. You are thinking that if you have X is multi-dimension, X1, X2, X3, you are probably thinking that this should be W1, X1 square, sorry, W1X plus, let me just write it a bit neat so that you're probably thinking that the polynomial Z is this. W0 plus W1x1 plus W2x1 square plus W3x1 cube plus W4 x2 plus W5x2 square plus W6x3 x2 cube. You're thinking that this should be the...
yeah, exactly.
That's true, but you also have cross relations between x1 and x2. So you have to take care of those as well. So think of this like this. Make a matrix. Here you have x1 and here you have x2, right? So you have x1 power 0, sorry. So you have x2 and x1. So you have, here you have x2 power 0, x2 power 1, x2 power 2. Here you have x1 power 0, x1 power 2, and x1 power 3, x1 power 3, 0, sorry, 1, 2. Then you have all combinations of them. So you can have a combination where you have x1 power 1, x1, x2 power 1, and x1 power 0. You can have a combination where you have x2 power 1, x1 power 1. You have a combination where you have, you understand?
Yeah, okay. So in this case, the number of the weights would be how to say, the number would be the how to say,
Number
the
of bases
dimension
square. It would be number of bases.
dimensions.
Yeah, it would be the number of bases square. If you want 3
Or
bases for x1, 3 bases for x2, it would be 9.
also plus W0, is that correct? Because it's a
W0, W0 is also included in this. So number of bases square, if it's 2D, also include W0. So just do it on a page and you would understand it. So
okay, I see.
you just do this x1 power I, x2 power j, x3 power k, where I, j, and k are in 0, 1, 2. Okay? Do this.
Yeah.
It would give you all bases, all possible bases.
Okay, okay.
And the
Yeah.
total number of bases would be 27.
Okay, okay.
Okay?
Yeah, it makes sense. Yeah.
It would be 3 times 3 times 3, which is 27.
Okay, so
Because you have 3 possible for x1, 3 possible for x2, 3 possible for x3.
okay,
Power
okay.
times.
Okay. So basically it how to say, the number of the weights would be equal to how to say, an how to say, for example, if it's the 4 dimensions, it would be 4 times 4 times 4 times 4,
Yes.
4 powered by 4. That
If,
would be the
if you take 4 number of bases, yes. If you take the maximum power to be 4, then yes.
Oh, okay, okay, thank you. Yeah, so this, yeah, is very clear to me.
Okay.
So, and also I want to ask some other questions about the following steps. You know, what I mean is, as you mentioned that for logistic regression model, which could be a kind of extension model compared with basically linear regression. So basically, what are the two extra parts in terms of logistic regression model compared with linear regression is that uh, after we have the hypothesis.
Non-linearity. Non-linearity is the extension. So you don't have non-linearity in linear regression, you have non-linearity in logistic regression. The sigma.
Yes. Yeah, yeah. So could I understand it in this way? Because I want to make it very clear about what are the major reasons that we must introduce sigmoid function and also binary cross entropy. So from what I understand, the reason why we must introduce, how to say,
Because we want
uh,
output to be probability. We want it to be the probability of a class, and the probability is between 0 and 1. That's why we include this non-linearity. We want the label to be between 0 and 1, the output not label. The probability of a label to be between 0 and 1, which we call y hat. That's why we include this non-linearity.
yeah. What I also want to know is that, you know, in the linear regression model, we don't have any loss function. The final step is we have the cost function and we can immediately calculate the specific value of the unknown weights. But
Yeah.
in terms of logistic regression model, we must have some optimization methods such as, you know, a gradient descent method.
Yes.
So
Because
what I want,
we cannot solve the equations directly. These are non-linear equations. We cannot solve them directly. So that's why we do gradient descent.
yeah. So what are the reasons that we cannot solve the problem immediately? Is it because we have two parts? First is we introduce sigmoid function.
No,
Second is we introduce,
I got it.
no?
The only thing is that it's a system of non-linear equations. Non-linearity came from both the loss function and the sigmoid. And because of the
Okay.
non-linearity, you cannot solve them directly. You have to use iterative techniques.
Oh, okay, okay. Yeah. So basically, yeah, it makes sense to me. Very clear. So yeah, I see. So my final question in terms of this model would be, I see in your notations, you know, in your notation about the previous video, the mathematical formula between linear regression model, which is a hypothesis function hx. In this case, you put the weights vector on the right side of the basically sample data. But in terms of logistic regression model, you the mathematical formula of z of x, you put the weights which is on the left side of the sample data x. Is this correct?
No. For logistic regression, linear regression, the hypothesis function h of x is wx. I call it, I think, a in my notation, but it's the same. Or I probably, let me write it like this. I call it
Yes.
this.
Yeah.
In logistic regression, the hypothesis function hx or y hat, we use both notation, sigmoid of wx. Everything is the same. The only thing which changes is the sigmoid.
Okay. 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 Yeah, it
Okay.
makes sense. Yeah.
Okay.
Yeah. Okay. Uh,
Okay. What about other people? Nawaf, you had some questions. Do you want to put them as well? Exercise 7.1. Okay. Any other people, if you guys have your questions, please put them in the chat. we can have a look at it. What is typically done? What is typically done to images with a higher resolution? Do we need to compress them first, like we did with DST, or do we use them as they are? What is the maximum? Well, there are no conventions for it. So generally, you can use large images. If you use large images, then you would have to use small batches. You cannot use large images and large batches because you would not have enough space, enough memory on your GPU. But generally, people do training on large, full resolution images as well. For example, ImageNet generally are adjusted to 224 by 224, which is significantly a significant size images. I don't know of any other images in classification which have a larger size than this. But whatever size, whatever resolution you can adjust your network, you just have to use a smaller batch size so that you don't have too many images in a batch and you have enough memory in your GPUs, on your GPUs. Okay, so let me share my screen. Yes, so 7.1. Okay, while we are waiting for this, other people, if you have any questions, if any question was difficult, there were any confusions, because we are reaching toward the end of the course, it's good to ask your questions and get them resolved. So please put them in the chat and we can do them together. It's taking a bit long. It's taking awfully long. Could someone send a picture of the question in the chat? Can you flatten an image to 1D and treat it as a 1D array? Yes, we can. That's actually what we did in yesterday when we trained a linear network, a neural network for MNIST images. We actually reshaped it, we flattened it and used it as 1D array, then took multiple samples of it, concatenate them into a matrix and used it in our training. Write a NumPy-based program to compute the forward and backward classifier to use the code to train a classifier for 2D data. We have actually done that. No, we have done this question. So it should be when did we study neural networks with NumPy? I think it should be day 7. So, so let me, this is an old example, but let me open it. So the output of the neural net does not depend on the batch size, since in the end we use all the available. No, of course, output of the neural network depends on the batch, because if you give it 10 inputs, you get 10 outputs. Then you can compute your loss and do all the back propagation and everything. The final weights of the neural networks are not, so to speak, function of batch size. Different batch sizes can give you same accuracy answers. But of course, the output vector that you get from your network depends on the batch. It could be the same size as the batch. So this was actually quite simple. We wrote a sigmoid function, a loss function, and then a find z. And then initialized our weights randomly, calculate the find, did the simple steps of finding z, finding the nonlinearity, finding the z for layer 2, finding the nonlinearity, and doing the back propagation using the back propagation equations. If people want, I can redo it. I can rewrite this code, but I think it should be fairly straightforward, right? Were there any specific questions that were confusing, or do you just want to like revisit it just to see how to do it? So let's do it. Let's get a line of code. Let's look at the shape of X. Let me see if I'm using the correct notation. X is small. Okay, so it has 2 rows, 200 samples. The first thing that we do is write our helper functions. So we need to find sigmoid. So let's write a function to get the sigmoid of our data. It takes in z and it returns 1 divided by np dot plus np dot x of minus z, right? This is the sigmoid. You need a function for linear layer. I'll call it linear 1. Or in fact, let's use the same notation that I've used previously. So I'll call it return z. It takes in an x, a w, and a b, and it returns w times x plus b. And then finally, we need a loss function. So it takes in a y and a y hat. So you can see that the output of the neural network has to be the same size as the batch because the loss is computed between the two. So they have to have the same size. And we have to return np.sum negative y times np log of y hat minus 1 minus y times np dot. So by the way, if there are any questions when I'm writing the code, please feel free to ask. And this has to be sum along x is equal to 1. We have to sum along columns because data is along columns. You can see that you have 200 columns of data. So once we do that, then we need to initialize our weight. So w, let's do something like np dot random dot rand n, and it should be, let's define the shape of our data. Number of input channels have to be equal to x dot shape 0, the number of rows of x. Number of hidden units is the design choice. We choose it to be 1. Number of output units have to be same shape as number of rows in y. So let's initialize the first layer. This should be n h times ni. B1 should be np dot zeros. And you can also do it randomly. Let's do it randomly. What should this be? This should be nh times 1. Let me copy this. For second layer, okay, and let's set a learning rate. So learning rate is maybe something like 0.001. Then let's run it for a few iterations. First, we need to do the forward pass. So we need to calculate Z1. Z1 would be X, W1, and B1. Then we have to do find the activation, which would be just sigmoid of Z1. Then we have to find Z2, which is A1, W2, and B2. Then we have to do the activation, which is sigmoid of Z2. Next, we have to find the derivatives. D with respect to W2 is, let's start with dz2. dz2 is a2 minus y. dw2 is dz2 times a, I think it should be a1 transpose, if I'm not wrong. And db2 is equal to np dot sum of dz2. X is equal to 1 because we have to add over data points, and keep them is equal to true. Okay, so we can copy it, and then dz1 is w2 transpose matrix product with dz2, and yes, we have to take the derivative of the activation function as well. So I think this should be this. It's a1 times 1 minus a1. I'm doing it from memory. Hopefully it should be fine. But let's see. This is easy1, easy1. And then we need to update our weights. So we have to do something like W1 learning rate times dW1, and B1 is equal to learning rate times dB1. Copy it. Let's do it for W2. Okay. Then let's save the loss. Okay, we have to calculate the loss. So loss is equal to return underscore loss of y and y hat, and let's append it. Let's plot it. Let's run it and see what's the problem is. It says z is not defined. Of course, it's not defined. It takes in the input x. Y hat is not defined. Yes, y hat is not defined because it's called a2. Okay, so I have a mistake here. It's y hat. And that's pretty much it. You can see that the loss function is decreasing, it's learning. So it's fairly straightforward. Uh, and Nawaf, are there any questions? Anything that was confusing or anything which was a bit tough that you want to discuss more? What would happen if we had selected batch size equal to 5 in the example with number recognition from yesterday? Nothing. It would be yx is equal to 1. Okay, so this is a good question. Yx is equal to 1 because we want to add along the data points. So the loss has to be added for each data point. Okay, the gradient has to be added for each data point. So that's why we add along the columns. X is equal to 1 means add along the columns. Okay, so let me open the exercise for yesterday. I think it was this one, if I'm not wrong. So the question that's asked is what happens if we choose the batch size 5 for yesterday's example? Nothing happens. It would train the same way. It would just choose the batch size to be 5. So each iteration, it would take 5 data elements, their labels, pass it through the network, take the 5 output, calculate the loss function between the 5 output and the 5 ground truths, take the back propagation and do the exact same thing. So let's do it. So let's make it 5. Let's say. It's going to take some seconds to download it. So we define our network. Everything is here. So it will just start training. It'll do exactly the same thing. Okay. While it's doing, while it's training, let me just go to the notes and explain it there. I think I'll be able to convert it. So what is the effect of batch size actually on the training? So basically what happens is that this is your neural network. Okay. You give it some data where, and so this is for PyTorch. When you're working in PyTorch, what happens is that your batch is along the rows. So you have n data points. Okay, this is your x, your data. Okay, x can have any number of dimensions. Let's say that we say that x is d-dimensional. You have d-dimensional data and you have endpoints. In our case, in the case of MNIST, this d was 28 times 28 because you had 28 times 28 pixels in the image. Okay, and this batch size n, it can be either 10 or it can be 5. That's what we choose. Okay, so if you have a batch size of 10, then y would also be of size 10, right? Y would also be either n equal to 10 or n equal to 5. Okay, the output of the neural network would be the same size as n. Okay, size, when I say size, I mean the number of data points, the d dimension. So let's say that this was the number of output channels is c. Okay, if you give it, so let me make everything neat. My data x is 10 times 10, 10 comma 28 times 28. This is the data. So batch n is 10, d is 28 times 28. Output channels that I'm looking for my data is 10. Okay, what would be my y, the size of my hat? The size of my hat would be c columns and n rows. Okay, that's always the convention. That's how your output of your neural network would look. Okay, if I make n equal to 5, you will have 5 rows and c columns. This has to be the case because you have to have the same number of outputs in terms of data points of a neural network as the number of inputs. If you are giving 5 inputs to a neural network, like 5 data points, you have to have 5 output data points as well, because that's how you will construct your loss. Is it clear? Aljaz, is it clear, or are there any, is there any confusion? Yes, but in this case, we have to set it to n equal to 10 because there are 10 expected values. No. We set it to 10 because we set collect 10 data points at any particular, in any mini batch. Okay, so n, okay, I think that's probably the confusion. That's what created the confusion. So let me, this number is the number of data points that you want in your mini batch. Okay, it can be 1, 2, 3, 4, 5, any number, doesn't matter. The number of outputs is defined by this number. This defines how many output, like you want, you want the output vector to have n C components. So this is C. Let me just comment it here. The columns is C, the number of components of the output vector. Okay. And here, this number is batch size, the number of rows in batch of data. Okay. And when we calculate y hat, which is which we call logits, so size. Oh, I'm sorry, I'm sharing the other screen. Okay, so let me come to my code again and let me explain these things. So this number is the number of, it's the number of this is the batch size, i.e. the number of rows in a batch. Okay, you can select it any number, 5, 4, 6, 7, 8, whatever. This is your batch size. Okay, this number here, it's the number of columns. This is the number of columns, i.e. C. That is the number of components of output vector. How many classes do you expect in your output? So this is represented by this number. Okay. Y hat, this is the output of your neural network. This is the output of the network, and its share is batch size times number of classes. Does it make sense now? Okay, perfect. That's great. So what we are going to do is, we are a little over the time. We're going to stop our lecture here. Tomorrow we will have an early session, like around an hour, on convolutional neural networks. Then we will have 1 hour session of just your questions. So we will open a coding book and you can ask any questions and we will solve those. please try to have as many coding questions as, for example, you did exercise, I don't know, 2.1, which was difficult, and you want it to be solved. So let's solve everything tomorrow so that you have like 3 hours left on your project. You can solidly work on that and not worry about anything else. Okay? I'm going to end the meeting now. Sorry, I went a bit over time. I'll see you guys tomorrow. Okay? Thank you.